Hello everyone. In the lesson 5, we are going to learn about classification of organic compound based on their functional group. So here functional group may be different functional groups are there like alcohols, ether, ester, acids, aldehydes, ketone. There are n number of functional group. After learning this lesson, you will be understand the different functional group, how they have been arranged in the given organic compound. So we are going to classify the organic compound. You know that the organic compound is a compound which is going to contain carbon, hydrogen and oxygen. Those compounds we are going to call it as organic compounds. So we can classify them in different manner. One of the methods of classification of huge number of organic compounds is by functional group. You already know that in previous lessons I have already explained that there are 10,000 more than 10 billion compounds have been identified, and every day nearly 1,000 new compounds have been identified and it has been added to that list. So you are going to have a huge number of organic compounds. It is very difficult to study all those organic compounds. In order to make our study systematic and easy, the chemists have classified these organic compounds based on their functional group into families or homologous series based on their functional group. If that is the case, what is a functional group? Functional group is a group or group of atoms which are joined together in a specific manner, which is responsible for characteristics of the chemical properties of that organic compound. That group or that family or that compound, we are going to call it as functional group. It is a tag, it is a group of atom or atom which going to decide the property, particularly chemical property of that organic compound. That bunch of group or bunch of atoms, we are going to call it as the functional group. Functional group of an atom is a group of atoms or a molecule that gives the molecule its characteristic chemical properties. You know that any organic compound is going to have both physical and chemical properties, but chemical properties mainly depends upon the functional group. Even the double and triple bonds are also considered as functional group. All the compounds the same functional group belong to a same family or same class. So since we are going to have a huge number of organic compound, the organic compound which going to behave in a similar manner, having the certain group of atoms joined together, such groups we are going to call it as a functional group. Only to simplify our work of studying, they have classified these organic compounds based on their functional group. In an analogy, you can think of one particular student have to identify in a huge college of nearly 3,000 students are there. One his or her parent will come there, stand in front of the gate, and he ask, this is the name of my ward, I want to identify her. It is very difficult because there are nearly 3,000 students are there. Out of 3,000 student, that parent has to identify his ward. Then what they are going to ask? We are going to ask questions. Whether your ward, whether your student, whether your daughter, she is belong to a science stream, art stream or commerce stream. If she belongs to a science stream, then 1,000 students of commerce, 1,000 students of arts have been diminished. So we have only 1,000. We have to search now out of 3,000. 2,000 has gone, only 1,000 out of 1,000 students we have to identify her daughter or his daughter. So then what we have to do? Then we are going to ask she belongs to which class, whether she belongs to a PUC or whether she belongs to a degree. There are 500 students for PU, 500 students for degree in science means. Again, if our student belongs to BSc, then 500 number is gone. Again, I have to search for out of 500, I have to search our ward, our daughter. Again, next question is that whether she belongs to a first BSc, second BSc, third BSc. In each BSc, you just imagine that 150 students are there. Then 300 students are gone. Now only out of 200 have to search our daughter. Then again I'll ask she belongs to which combination. Then she will tell CBBT or CZBT, some combination she'll tell. Thereby it's easy to identify. There will be roughly 50 students are there. Out of 50 students have to identify a daughter. This is the way we are going to narrow down our understanding, make it easy to understand that particular organic compound. So here they have classified, how we are classified as science background, arts background and a commerce background. One type of classification. Another type of classification, she belongs to PU or degree. Another classification, whether she belongs to first year, second year, third year. Later we are going to go into combinations like that. Here also based on their functional, it can be classified, organic compounds can be classified in a various manner. One of the manner is that we can identify the functional group present in them. Since the functional group is the one which is going to decide the property of that organic compound, all the organic compound having the same functional group, they are going to behave in a similar manner. Thereby we can generalize the study to certain extent based on their functional group. That's the way we are going to classify these organic compounds based on functional group. How these functional group classification useful? One of the main reason for classifying the compounds by their functional group is that it also clarifies their chemical behavior. It classifies the chemical behavior. All the organic compound having the same functional group, they are going to behave in a similar manner. But there will be some exceptions are there, but generally based on their functional group, the conversions, the transformation from one form to another form takes place, thereby doesn't affect the other part of the molecule. So therefore it is easy for us to understand, easy for us to study, easy to classify the compounds having the same functional group. They are going to behave in a similar manner. For example, when you consider alcohols, they are going to have the formula ROH. Here OH is called as the functional group transferred into different compounds without changing the structure of an hydrocarbon R. Here R is an hydrocarbon, that may be alkyl, alkenes, single bonded compound, double bonded or cyclic compound, whatever may be the R is there. So just if I want to change, OH group is there, I can convert that OH group into OH group into Cl group or Br group. So those compounds we are going to call it as organic halides. Here R I am not going to disturb, R remains same like that only the OH group. So R may be a open chain compound, cyclic compound, it may be saturated or unsaturated, but here when you do the reaction, when you consider the organic compound having the functional group OH group, irrespective of the R group, all the compounds having the functional group OH are going to behave in a similar manner. When you want to convert that into organic halide, you can, without disturbing R, you can convert only OH into L. That's a speciality of functional group. Similarly, if I want to convert into ether without disturbing R, I can convert. Without disturbing R, I can also convert them into amines. So amines means RNH2. So this is the way I can do it. Here I am converting I am doing the conversion, I am doing the transformations from one form to another form without disturbing the rest of the molecules, taking into consideration only the functional group. Such groups we are going to call it as functional groups. So I told you even the double bonded and triple bonded molecules also going to consider as a functional group. If it is a single bond, they are called as alkanes. If it is a double bonded, alkenes, triple bonded, alkynes. That's going to classify. Apart from this, there are other functional group having different class, different families. Alcohols means they are going to have OH group. Aldehydes means CHO group. Ketones means C double bond O. Acids means COOH group. Esters COOR. Amines NH2. Amides CONH2. Nitriles C triple bond N. Thioalcohols SH. Acid chloride COCl. Like that we are going to have different functional group which going to decide the property of compounds based on their nature, based on their groups. Such compounds we are going to call it as functional group. So organic compounds are also classified based on their functional group. Depending upon the group, depending upon the family, depending upon the functional group they are going to have, we are going to classify these organic compounds into alcohols, aldehydes, acids, etc. And also I told you we are going to have another term that is called as homologous series. The organic compound having the same functional group, they are going to belong to a series, and that series we are going to call it as homologous series. A series of compound having the same functional group, have the same chemical properties and two consecutive members differ in their molecular formula by CH2. Such series we are going to call it as homologous series. All the functional group compounds, they are going to belong to a homologous series. The homologous series is the series of organic compounds having the same functional group, having the same chemical properties, and the difference between the two consecutive members will be CH2. Such groups, such series, we are going to call it as homologous series. Homologous series is a family of compound with the same functional group, with the same general formula and similar chemical properties. Each member of the homologous series is called as a homologue, and the phenomenon is called as homology. Homo means same. They are going to have same functional group and they are going to have either increase and decrease by CH2 group. Such series, we are going to call it as homologous series. These homologous series will going to have some certain characteristics. The members of the series have same functional group, and the two consecutive member either in increasing order or decreasing order, they are going to have they differ in their composition by CH2 unit. For example, alcohol. First member is CH3OH, second member is CH3CH2OH, and third member is CH3CH2CH2OH. Between CH3OH and CH3CH2OH, the difference is CH2 group. Similarly, CH3CH2OH and CH3CH2CH2OH, again difference is CH2. So such compounds belong to a homologous series. The compounds which are going to have same functional group, they belong to a homologous series. These members of the homologous series are represented by the same general formula. So this is made in order to understand, in order to study the organic compound in a easier manner. This is a way, the systematic way they have classified the organic compound. So they are going to have the general formula. For example, alcohol, CnH2n plus 1 OH. Aldehyde, CnH2n plus 1 CHO. CHO is a functional group on aldehydes. So all the aldehydes, if they belong to a homologous series, they are going to have this general formula. For example, when you consider alcohols, they are going to have the formula ROH. Here OH is called as the functional group transferred into different compounds without changing the structure of an hydrocarbon R. Here R is an hydrocarbon, that may be alkyl, alkene, single bonded compound, double bonded or cyclic compound, whatever may be the R is there. So just if I want to change OH group is there, I can convert that OH group into OH group into Cl group or Br group. So those compounds we are going to call it as organic halides. Here R I am not going to disturb, R remains same like that only the OH group. So R may be a open chain compound, cyclic compound, it may be saturated or unsaturated, but here when you do the reaction, when you consider the organic compound having the functional group OH group, irrespective of the R group, all the compounds having the functional group OH are going to behave in a similar manner. When you want to convert that into organic halide, you can, without disturbing R, you can convert only OH into the organic compounds based on their functional group. For example, homologous series of alkane, CnH2n plus 2 is the general formula, and the difference between those two is CH2. This is a series we are going to make. Methane, ethane, propane, butane. Similarly, alkene, if you consider ethene, then you are going to have propene, then you are going to have a butene, pentene, etc. Similarly, homologous series of alcohols and homologous series of aldehydes. These homologous series, they are going to have the general formula, and the first member and the next member, the difference will be C group. So remember, carbon has only 4 bonds. We should not just consume hydrocarbon fuel, but use it to develop the nuclear power and renewable energy sources. All these hydrocarbons, fuels, whatever the fuels that we are going to use, petrochemicals that we are going to use, just we are going to consume, just we are going to burn it. But we are going to use our chemistry knowledge to develop the nuclear power and also other renewable energy sources. Thank you. All the best.